before we do this section of notes, there's two things we need to review. The first thing we need to review is solving systems of equations. Okay, so this is our little review thing. So, solving systems of equations. This is something you should have learned about last year. Yeah, perfect. Okay. So far you probably have learned these methods of solving systems. They're solving by graphing. So solving by graphing would mean that you graph the equations and you see where they cross, and the solution is the x, y points where they cross. Do you remember ever doing that? Please, yes, I hope. So solution is where they cross. Okay. So then you would have learned another method called substitution. And that's where you take one of the equations and you solve it for one of the variables and you plug it into the other equation and then you find that answer and then you plug that back in to get the other answer, right? And then the third one you've probably already learned at this point is called elimination. And elimination is where you line up the equations in standard form and you add them together and get something to cancel out, and then you find one of the answers and plug it back in to get the other answer. Does that sound familiar? Okay. This chapter we are learning 3 more ways. We will learn 3 more methods that all use matrices. So what do you think the other thing we need to learn about today is? Maybe you've never done matrices before. Anyone ever done matrices before? You're not sure? Maybe a little bit? We'll see. Okay. Before we start talking about matrices, though, let's review some of the solution types. When you have a system of equations, there's different ways your solutions can turn out, okay? So, types of solutions. Your solutions can end up being, here, let me look at this other thing so that I am making sure I'm giving you the right information. Okay. You can have a set of solutions that's what we call consistent. And if it's consistent, you have exactly one set of solutions. So that means you get one x value and one y value that make those equations both true. Okay? The other type of solution you can get is what's called inconsistent. When that happens, there's actually no solution. And back when you did solving by graphing, the solution by graphing would have looked like parallel lines. They would have never crossed. Does that sound familiar? Okay, so if the lines were to never cross, they never have answers that work in both equations, then there's no solution. Okay? When that happens, when you solve using substitution or elimination, the way that you're able to tell there's no solution is you might get something like 0x equals something that's not 0. And is that possible for 0x to equal something that's not 0? No, because 0 times x will always equal 0. So if you get 0x equals something that's not 0, it's just not possible for that to even happen. So that's how you know that it's no solution. Okay, and then the last one we call dependent. Dependent has infinite solutions. I don't think you've probably heard these names before, but, oh, you have? Cool. Infinite solutions. And graphically what that is you actually, the line is the same line. And algebraically, what that ends up looking like is 0x equals 0, which is always true. And and so that's why there's infinite solutions. Okay, do those sound familiar? Because you will run into all three types as you're doing these problems. Okay, next thing we need to talk about is what a matrix is. A matrix is a rectangular arrangement of numbers. And the really cool thing about matrices is that it's a way of organizing the numbers without the variables, so it's easy to have the work done by a computer or a calculator. Okay? So those of you that think of the movie The Matrix when you're thinking of the word matrix, it sort of has to do with computers, I guess, sort of, because matrices are used, I don't know. Anyway. All right. I've always had people ask me that, but it's R-rated, so that would be against district policy. Yes. It's the first R-rated movie I ever watched. Since then, I've watched many more. I can do permission slips for PG and PG-13, but not for R. Sorry. Okay. I did not mean to start that discussion. Here we go. Shh. This is an example of a matrix. We're going to use this example to learn about things, okay? Notice how the matrix is enclosed in brackets. You make the brackets smaller or bigger depending on how many numbers are involved. The numbers in the matrix are called elements. Okay? We can, since this is matrix A, the individual numbers in the matrix, the individual elements can be named, if we wanted to talk about them, with a little a and then two numbers. And those two numbers are referred to as the index. And the index tells us the row and the column. So, for example, if I was looking at A2, 1, that doesn't mean A sub 21, it's A row 2, column 1. What number in this particular example is that element? It's the 4, because it's row 2, column 1. Okay? This is always done with a capital letter. Okay? And then the next thing that's going to come out important within the next few lessons, the next few days, is that the dimensions of a matrix, when it asks you for the dimensions of a matrix, it is the rows by the columns. You always do number of rows first and then number of columns. So what would the dimensions of this particular matrix be? This particular matrix is a 2 by 3. Okay? So yes, you've kind of learned about that stuff before a little bit? Yeah. Cool. Okay. We're going to stop at this point.